Welcome to Understand Chemistry. This is Dr. Bilal. Today we are breaking down suspension polymerization, a vital industrial process often called pearl or bead polymerization. The suspension polymerization system consists of two phases. First, the continuous phase, which is primarily water, but it is fortified with stabilizer like polyvinyl alcohol to prevent droplets from merging. An electrolyte is sometimes also added to control further the droplet size and stability. I will come again to explain further this point later in this video. The second phase is the hydrophobic phase. This contains the monomer like styrene and an oil-soluble initiator like benzoyl peroxide. Now let us see how stabilizers work. A schematic diagram of stabilizer interaction with the droplet has been shown here. A stabilizer like polyvinyl alcohol has hydrophobic carbon chain that interact with the hydrophobic monomer, while pendant hydroxyl group of polyvinyl alcohol are oriented itself towards water phase. This avoids merging of droplets again. Here the core concept is that polymerization does not happen in water. Rather, it occurs inside each individual monomer droplet. This is why we say each droplet acts as its own tiny microreactor, each droplet mimicking a bulk polymerization system on a microscopic scale. This ingenious setup solves two major problems of traditional bulk polymerization. First, the water continuous phase is excellent at dissipating the intense heat generated by the reaction. And second, the viscosity remains very low in the reactor because the water is in the continuous medium, making it easy to stir and handle. The entire process is run by mechanical agitation. The shear from the stirrer determines the size of the droplet, which typically ranges from 50 to 500 micrometer. Now let us look at the key ingredient that make this process work, starting with the monomers. A wide range of water-insoluble monomers are perfect for suspension polymerization. The classic example is styrene, which produces crystal clear polystyrene beads. Others include methyl methacrylate for plexiglass, vinyl chloride for polyvinyl chloride, which form excellent uniform beads, and even specialized monomer like tetrafluoroethylene for Teflon. It is also crucial for creating copolymer like with acrylonitrile, or for making permanent hydrogel beads by adding cross-linking agent like divinyl benzene. Since polymerization happens within the droplet, we need oil-soluble initiator that dissolve in the monomer phase. Initiator for styrene and vinyl chloride is benzoyl peroxide. For acrylate and methacrylate, isobutylonitrile or AIBN is often more effective. But perhaps the most critical component is the stabilizer, dissolved in the water phase. Compounds like polyvinyl alcohol or hydroxypropyl cellulose perform three essential jobs. They prevent coalescence of the droplet, means the merging of the droplet. They control the final particle size, and they dramatically improve the suspension stability throughout the reaction. We often add electrolytes like sodium chloride, calcium phosphate, or magnesium carbonate to the aqueous phase. Their primary role is to modulate the ionic strength of the water. By doing this, they reduce the electrostatic repulsion between the charged head group of the stabilizer molecule. This allows the stabilizer to form denser, more cohesive protective film around the monomer droplet, which further enhance stability and give us a greater control over the final particle size. This principle of stabilization is so versatile that it can be flipped to polymerize water-soluble monomer. This is called inverse suspension polymerization. Here, the entire system is reversed. The continuous phase is now an organic oil like hexane or toluene. The monomer are water soluble like acrylic acid or the acrylamide. These are the droplets. The initiator must be water soluble too, like potassium persulfate, so it dissolves inside the aqueous droplets. And crucially, the stabilizer must be oil soluble like sorbitan monostearate to hold the water droplet apart within the oil. This technique is the industrial workhorse for producing the super absorbent polymers you find in products like diapers. If you want to learn more, I recommend checking out classic books like Principles of Polymerization by Odian or Polymer Chemistry by Karahar. This explains the key ideas in the polymer science in a clear and detailed way. Thank you for your time and attention. If you have any question, please feel free to leave them in the comment box.